There's nothing that can go wrong.
Yeah.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 319, Experimental Archaeology, Demoscene Oscilloscope Music, and Electronic Memories. And I'm having deja vu. I cannot believe it. First up in Hackaday News, we just recorded the podcast for about 2 hours.
No, we didn't.
And Dan's like, hey, wait, I wasn't recording. I'm like, oh, I wasn't recording either. So here goes. Podcast episode 319, take 2, clap. Thank you. So pardon us if either we sound well rehearsed or punch drunk. We are a little of both.
Oh, God, yeah.
First up in Hackaday News, SatTrack Cam Leiden is tracking a Venusian spacecraft that is coming our way. This isn't a spacecraft that's been to Venus. It's a spacecraft, though, that was scheduled to go to Venus. This is Cosmos 482, which was going to be the lander from a failed Soviet Venera mission back in 1972, has been orbiting around the Earth. And Professor Marco Langebroek, that is SatTrack Cam Leiden, has been following it, and it is predicted to come landing down in about a week. If you're listening to this now, the margin of error is still fairly large, but it looks like, best guess as of recording, May 10th, 6 a.m. UTC, plus or minus 2.8 days.
Now, is the margin of error whether it's going to hit us or not, or just when it's going to hit us?
No, it's in Earth orbit, so it is 100% going to hit something on this planet.
And that's something better watch out, because this sucker is going to try to touch down, so it is a big chunk of metal.
It is a 500 kilogram chunk of instruments and metal meant to plow through the Venus atmosphere. So it probably is going to touch down on Earth, I guess. I mean, it's got heat shields and stuff like that. It's also got parachutes that we're supposed to deploy. Whether the pressure triggers, A, will work in the Earth's atmosphere, or B, will work after 50-something years, is to be determined. But this is all going to happen in a week and a bit, plus or minus 2.8 days. So stay tuned. Keep hitting refresh on Marco's website and get the updated tracking info. If it doesn't hit anybody and hurt anybody, this is going to be awesome and historic. If it goes down in the ocean, it's going to give treasure hunters something to do.
I'd love to just see photographs or video of the track when it comes back in. It could be quite spectacular.
In other Hackaday news, I learned this week, You Wouldn't Steal a Font is a write-up of the You Wouldn't Steal a Car anti-copying campaign of the early 2000s that showed up on DVDs. It's kind of got this font that looks like it's typewritten, but a little bit ghosted out in places. It turns out they stole that font, or rather failed to license it properly. It is FF Confidential, designed by none other than Joost van Rossum, who is Guido van Rossum, the inventor of Python's brother. If you read the comments on the Hackaday article, not only did they steal the font, but also the music in the background is also unlicensed. And the irony that this comes from a copyright enforcement campaign is pretty damn rich.
And what must the Von Rossum family reunions be like? They must be pretty cool.
Oh, I can't even imagine. Yeah. Geek Central. And last up, some sad news. SIGROC website down after hosting data loss. SIGROC, with its graphical front-end pulse view, is probably what you're using if you're using one of those little cheap 8-channel logic analyzers. But it can do a lot more than that. It can automate a whole bunch of test equipment, so you can read the data in from your multimeter, combine that with your automatic voltage meter and your scope and your logic analyzer and everything all at once. SIGROC is a marvelous piece of software. I have no idea why they are not running it on version control and this isn't put up somewhere more safe. But this time looks like SIGROC is down for good. Good news, of course, is that everything has been backed up on the Wayback Machine, so should be able to get most of the documentation back up from that. But just a reminder out there to take care of your local, absolutely crucial open source software infrastructure and the people who write it.
This is a journey into sound.
What's that sound?
What's that sound?
All right, now it's time for What's That Sound? This is a Guess the Sound week, so I've got a brand new sound for Dan who hasn't heard it for the last 2 hours.
Beep.
But for the record, he absolutely nailed it. So not only did he tell me what it was, but he told me like some history and background of it. So with the first short spoiler, it's a musical instrument. Let's roll the sound and you out there can guess what it is. If you know what that sound is, head on over to hackaday.com/podcast, scroll on down to the What's That Sound bit, click the link, enter your handle, your best guess, and next week will be the reveal week where we will pick randomly among the right answers and get somebody a Hackaday podcast t-shirt. All right, my first hack this week, weird and wonderful VR, MR text entry methods all in one place, is research for the CHI conference on human factors in computing systems from a large research group composed of, drumroll please, Arpit Bhatia, Moaz Mugrabi, Dr. Abdikarim, Massimiliano Di Luca, Mar Gonzalo Franco, Karan Ahuja, and Hasti Saifi, who went out and curated all of the strange and interesting text entry methods you can use in VR, AR, XR, and kind of any sort of fake reality out there that you can think of. Their website is absolutely fantastic, and you should just go over there and scroll down. They've got animations of most of them, and it runs the gamut from fake floating typewriters that you try to type on, or the ones that you try to do with your eyes, but then a bunch of stranger input methods where like you subdivide your fingers on one hand into keys and tap on them with your other hand, or Morse code, or typing on the front of the VR goggles that have a touch sensor added to them, pizza wheel pie rotating things, all sorts of crazy ways that you can enter text into a VR/AR environment. What's really cool about the paper, and you should click on through, it's up at the top of their webpage, is that they also went on to analyze all these methods. And so they rank them by things like speed, accuracy, convenience, how tired the person gets after using it, how easy it was for them to learn. They take the dates that all of these different methods were introduced and kind of say, are things getting better or worse over time? And their results, I will spoiler for you, you don't even have to read the paper. For things like speed and accuracy and ease of use, it is not a surprise that things that were more like a traditional typewriter scored higher because, you know, after all, you're typing in text. But things that they found mattered were things like being able to use all your fingers at once, and haptic feedback, and knowing where your fingers are. All things that you kind of get for free when you use a regular keyboard, and things that you don't get if you have to look at letters on an imaginary keyboard with your eyes, or if you have to like dance the letter A for it to type an A. You know, I mean, some of the ways that they try to enter text in VR and AR are just super contrived, and that is kind of brought out here. The other thing that we get is that the trend over time is not particularly conclusive. They say there was a spike with the HTC Vive and the Oculus Rift and Touch controllers, but basically they haven't found that typing speed, you know, virtual typing speed has been improving over time. And I think basically their conclusion is that that's because no one has really yet come up with a compelling virtual typing interface. One of their recommendations that comes out of this is that a real keyboard, of course, ticks all the boxes. A real keyboard does exactly what you want for something to type in letters on. And that shouldn't be any surprise to anyone. But maybe the new wave of VR glasses that have better and better front cameras on them can make for an augmented reality type situation where you're actually typing on a physical keyboard, but you get to see it through the front-facing camera lens. I mean, it kind of breaks the immersion of whatever virtual world you're in, but if it lets you type faster and saves you from having to like hunt and peck with your finger in the middle of the air where you just keep pressing through this, this imaginary floating keyboard, I think it's probably worth it.
I'm kind of wondering why we need to do this.
Right?
Why take, your TV, for example, your smart TV, and you're going to search on Netflix for, whatever movie or show you want to watch. And they pop up that crappy keyboard that you use with the arrow keys on your remote. Terrible experience. Absolutely horrible. But I'm not trying to write a novel on that keyboard. I'm trying to type in, The Expanse or whatever so I can go watch some TV. I'm willing to accept that limitation because it's not the place that I'm trying to compose the next, great American novel. If I'm going to do that, I'm going to sit down at a keyboard and put my fingers on it. So I'm just wondering why we're trying to improve things like typing speed in the AR world. Who's going to want to do that? I mean, you've got a headset on that presumably can get audio information. Why don't you just do speech to text? If you've got some text to put in, that's more than just a couple of characters. If it's a couple of characters, bing, 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 whatever, and it was a terrible experience, but it's all over, I'm feeling better now. If I've got more important things to do or more extensive use of the keyboard or more extensive use of text input, then do something else. Talk. Go to a keyboard. It's mixed reality. Why don't you just go to a physical keyboard and type?
If all of these input methods are so difficult, is that a sign that damns vocal recognition? Is voice recognition really that much worse than, trying to remember pinching which finger or, pinching Morse code in the air trying to type, right? Like, How bad is voice recognition that that's a reasonable thing to do? Super good question for which I have no answer, except that all of these crazy input methods are awesome. And if you want to
they're awesome. Yeah, for sure.
if you want to implement crazy input methods yourself, here is a phenomenal potpourri of them, and you will doubtless be inspired if you just scroll through it. I think that's the sense in which Donald Papp, who wrote this up for us, put it out there. He said, it's just fun to see and browse what kind of unusual solutions people have come up with that go beyond, floating oversized virtual keyboard. And yeah, I totally agree with that sentiment. So go check it out.
Okay, first up for me, again, first up for me is Clickspring's experimental archaeology concentric thin-walled tubing. We all know Clickspring as the horologist par excellence who builds beautiful, beautiful clocks and other similarly intricate mechanisms and with extremely good video quality. It's always a joy to watch a Clickspring video. His particular point here with this project is, as the name implies, experimental archaeology, where he's looking at the possible ways that you could have made some of the things that appear in ancient mechanisms, like the Antikythera mechanism, which is the analog computer that was found at the bottom of the Aegean Sea, and it's at least 1,000 years old, and it appears to have some very intricate pieces and parts that almost defy explanation as to how they were made. And his point here is to defying the explanations and saying, yeah, it was entirely possible to make these things with the tools and materials they had on hand at the time this was made. And what he does here is he makes a series of concentric tubes, which you would need in a mechanism like the Antikythera, the same as you'd need in a clock that was showing you hours, minutes, seconds. You've got, a tube on the outside that sweeps the hour hands, one on the inside that sweeps the minute hand, and one that on the inside that does the seconds. And they all have to connect to a gear train, and they all have to be very precise relative to each other so that the mechanism will work correctly. He starts with a rod of brass, and puts it on his hand-powered lathe and is able to achieve a fit between these 3 or 4, I'm not sure if it's 4. Yeah, it's 4 tubes, or 3 tubes and a rod. And he's able to achieve a gas-tight fit on these rods with nothing more than this bow-powered lathe sharp tools, and some know-how. I think the real eye-opener here for me was the creation of Red Rouge, which he did from scraps of iron filings from the bench, which he collected up, ground in a mortar and pestle, and let them rust, dried them down, ground them up some more so they're very, very fine powder, and then resuspended that in some olive oil, and it makes a paste that is a very, very fine abrasive that he was able to lap these tubes to the proper finish and the proper diameter to achieve this, like, literally syringe tight finish. He puts his finger on one end of the tube, pulls the piston out of the other, and you get a nice pop, and it was clear that was holding gas pressure. Wonderful project, and as always, great video production quality. Love watching anything that Chris does, and this one really, I just like the idea that, you know, there's someone out there who's doing the kind of experiments to just kind of nail it in your head that there's very little that we do today that we're capable of doing today that humans were not capable of doing 1,000 or 10,000 years ago. We're the same software running on the same hardware, and we've all got the same hands that we used to. There's no other bones that have evolved over time. There's no other muscles that the attachments are all the same for the muscles. We're all the same hardware. The wetware running on our brains is the same stuff that was running 10,000 years ago, 100,000 years ago, 300,000 years ago. Same stuff. And all you need really to be able to achieve things like this are patience and time and the ability to communicate between people, to share experiences so that, this worked here and this didn't work. And, if you go get this particular kind of sand, it makes a really good abrasive for metal or finishing or whatever. All those kind of elements that we use today to achieve precision results in metalwork and all the other things that we do. Same thing you could have done 10,000 years ago.
But that also kind of points out what was struck with when I was watching this Clickspring video, which is that I think a missing part of it, he does everything on period equipment and, or at least period available equipment. But the part that isn't period available is kind of his knowledge about turning things. And, he does point out that there are ideas, or at least drawings, of cylinders that are gas tight with respect to each other. But I don't know if they were ever manufactured. He doesn't know if they were ever manufactured. Part of the story about human progress, especially since the cave dwellers, it's not that we people are that much different, but that our kind of accreted knowledge and the tools we've built and the whole universe around us has also changed. So I don't know. I think he's holding one factor constant, but the one that has changed is that he is an exceptionally trained watchmaker.
Yeah, and that's true. I mean, he's reverse engineering something, and that comes with all of that program knowledge, like you said, and the forward engineering that presumably was done, when this was accomplished the first time, it was probably a whole lot harder. And if you just found a piece of concentric tubing like this in the archaeological record and you never found a precursor that indicated, somewhere along the way, someone had figured out how to, take a piece of brass and turn it into a rod, say, just a nice round, cylindrical piece of material. Then you might question, like, well, where, how did they, I can see how they get from rod to tube, but if we never find the rod, how did they get to tube from, lump of copper and lump of zinc? So yeah, I mean, the forward engineering was probably a whole lot more difficult than the reverse engineering. On the other hand, we have the Antikythera mechanism, which has concentric tubes in it, and we know the approximate age of it. So, it exists. Someone did it. And if you don't say aliens, then
I do not
it's humans.
Say aliens.
And it's got to be humans. So there has to be a mechanism for that to have happened. And, and it didn't need reverse engineering from them at the time. It needed forward engineering, and it obviously happened.
It made me think sometimes about the demo scene too. And this is a weird segue into my next one, but the the things people do with Commodore 64s and their graphics in 2025 is insane relative to what they could have done and what people were doing with it back in the 90s, right? And so there
Yeah.
is the Commodore 64 isn't any different, but like all of our tooling and all of our ideas and just the ideas of what are possible have changed since then. And that still blows my mind. And that is a segue to my next hack. Amazing Oscilloscope demo scores the win at Revision 2025. And this is the story of Primer, which is a audio video on an oscilloscope demo by the Bus Error Collective members DJ Level 3 and Marv 1994. And this is oscilloscope music, but it is the banginest oscilloscope music you've ever seen. And it comes along with superb graphics. And if you don't know oscilloscope music, the scam here is that the right channel and the left channel of the audio, when you play them into an oscilloscope set on XY scan mode, produces the visuals. And this one is just phenomenal. Like, the music's great, the video's great, and just the fact that it's done in this bizarro esoteric way is so fantastic. We learn through the write-up here that they used ASCII render to do some of the art, and for composing the music, I think they used standard modern tools like Ableton 11 or something. You should absolutely watch this one though, because me talking about demos is like dancing about architecture. This is no good. You have to go watch it. It's a banger, and it gets better and better and better as it goes along. At some point, they've got, entire rasterized images dancing and fading in and out of each other. It's just so rockin'. I absolutely agree with someone in the comments who said, now what you need to do is take this with some laser galvos and project it on the wall. But I agree with the next commenter also, who said nobody has laser galvos that can move that quickly. And that's the unfortunate downside of this. But if you want to experience it yourself in the confines of your own home, as long as you've got a glowing 5-inch by 5-inch phosphor tube, you should be able to do so, because they have the FLAC files up on their website. So you can download the actual audio that will make these graphics for you. And well worth doing.
Yeah, and seeing oscilloscope music, especially like Beam Fenderson's, dancing mushrooms and all that stuff, was the one and sole reason that I bought an analog oscilloscope. I went on eBay and tried to find one. I got an old Tektronix 765, so it's sitting in a closet. But one of these days, I'm going to haul that thing out, fix it up, and do some sick demos like these. Plus, maybe play some asteroids.
If you haven't been following the oscilloscope music scene, there's actually some really great stuff going on. You mentioned Beam Fenderson, and I think we covered him last in 2014. But his work inspired a whole bunch of people, and there is kind of a oscilloscope music scene. I ran into it last year or 2 years ago when I was working on the Vectorscope badge, because I thought that would be a cool thing to show, and a bunch of people at SuperCon hacked oscilloscope music into it, which I thought was lovely. If you haven't checked out that scene, there's a whole bunch of new tooling around to make porting your images and mixing your images and your music together even easier. So it's not as hard as it used to be, but that just means you have to focus on the art part of it more and more and more. I think that was what in the end got our Bus Error crew not just the Wild Category Award, which is for a demo done on something strange and non-conventional, but also the overall crowd favorite award. Like, it's that good. Go check it out.
Alrighty, next up for me. Look, it's a knob, it's a jack, it's Euronob. This is from Mitzella, who does a lot of jewelry and LED, tiny LED and micro soldering projects. But this is a return to his synthesizer builds. This one's in support of making eurorack modules a little more user friendly. If you're not familiar with eurorack, it's a really cool kind of modular standard for synthesizers. And the problem with them is as they get a little more complicated, they get a little crowded on the front panel. You want a knob to control a control voltage or some function on this module. But you also maybe want a jack where you can do a control voltage from another module or take an audio signal and pipe it into this module. So you want both, but they both take up real estate. How do you resolve that? Well, Mozilla figured out a way to do that. And when I first looked at this project, I was like, okay, great. He mounted a potentiometer to a PC board and put a knob on it. Wow, let's write that one up for Hackaday because it's a real, real state-of-the-art stuff. And that's what it looks like. It looks exactly like that. There's a knob. You can turn the knob and some LEDs light up on this demo PC board relative to the position of the knob. However, pops the knob out, just pulls it out of the PC board, and instead of being a knob connected to an encoder or a potentiometer or anything like that, the shaft of this knob is actually a 3.5 millimeter audio plug. And what it was plugged into was a 3.5 millimeter audio jack that's soldered to the PCB. And once he pulls out the knob, he can plug in a patch cable and then put a control voltage in that'll do the exact same thing that twiddling the knob did before. The secret behind this is that the body of the control that he's operating is not a potentiometer or an encoder, but rather a 3.5 millimeter audio jack that is sitting above a magnetic detector, and the kind that will detect a rotating magnetic field, which is provided by a tiny neodymium magnet that's been attached to the tip of the 3.5 millimeter plug by kind of hogging out a slot in the metal and gluing this magnet into it. So when you plug the knob on the shaft into the audio jack, that magnet spins over the magnetic encoder, and then a microcontroller, a CH32V something, interprets that and lights up some LEDs to show you what position your knob is at. Unplug it, the magnet goes away, the audio jack receives a control voltage and does the same thing through the A to D on the microcontroller. Absolute genius. I thought it was anyways. I really enjoyed the idea. I don't know how mechanically robust this is going to be in the long term. There's no bearings or bushings or anything. It's just the shaft is just the jack turning within the socket of the jack. Or wait, plug, jack. I'm getting my plugs and jacks mixed up. But you know what I mean. Mechanically, that's probably not very sound. But then again, this isn't a wheel on a robot or an axis on a CNC printer or something like that. It's not a high wear sort of location. If you're just going to, every once in a while twiddle a knob to get the right sound, I think this is probably more than robust enough. Also, a bit of mechanical allowance that had to happen for this to work, because there was no clearance below the tip of the plug when it was seated in the jack. He needed to elevate that assembly up off of the PC board so that the magnetic sensor chip had room. So it's basically just like a mezzanine level of board that with a big cutout in it that allows magnetic sensor to be underneath the magnet. Yeah, really great all around. It's a proof of concept. It's not really designed to do anything yet other than what it's doing, which is just light up some LEDs. But you could actually see how this would be a super useful addition to a eurorack module.
Yeah, it's a brilliant multiple use of the space, and it's just the craziest, most out-of-the-box idea/solution ever. All right, my last hack this week. 2 weeks ago, we were talking about pneumatic soft robots, and then this week, Robot gets a DIY pneumatic gripper upgrade from Taser in the mail, and have to write it up. And this is a really cool gripper hand thing. It's actually more of a wrapper than a gripper. It's a long it looks like a shoe insole or something. It's made out of silicone, and it's got puffy inflatable pillows on one side and a piece of non-stretchy fabric embedded in the silicone on the other side. So what happens is he pumps it up, the pillows expand, the fabric doesn't, and that makes it curve. On the inside, he's got little knoppy gripper shapes, I think just to give him a little bit more friction. But that is the hand. So apply air pressure to it, it curves around and can pick up like a pint glass or something. Really, really cool. And he shows us how he made it, which is, of course, a bunch of 3D printed molds and a bunch of pouring silicone in there. It's actually a multi-step procedure because he has to embed the fabric in the one side and then get the chambers on the other side to line up just right and everything. He also 3D prints all of the manifolds and stuff, which is pretty interesting. He shows how he takes an off-the-shelf pressure fitting and kind of embeds it into the 3D printed plastic. He actually uses a bunch of heat, which he kind of presses it in there and melts it while screwing it in, which makes the pressure fitting seat nicely, I guess, against the plastic. Although the engineer in me says the right way to do this is probably with an O-ring. But, whatever. He gets it working, and he connects it all to his fantastic desktop robot arm, which is driven by kind of the strong version of hobby servo motors. Yeah, it gets the job done. He demos this whole thing, inflating, deflating, picking stuff up, moving it around. It's pretty cool for a proof of concept. I have to say, the one thing that always drives me crazy about these home-built servo-powered arms, and this includes the one I have built many years ago, is that those servo motors, especially the hobby servos, just have so much play in them and the movement's so janky. But most of all, you can't control the speed. So you say, go from point A to point B, and it goes as fast as it can from point A to point B. And that is a bummer when you want to move a robot arm smoothly and fluidly from point A to point B. And that reminds me of one of my favorite hacks of all time. Vastly improved servo control, now without motor surgery, is the second and very refined version of a project by Adam Beckstrom to replace the brains inside a normal hobby servo with smarter brains that let you do not only absolute position sensing, but command it to move with a given velocity. And the results he gets out of that for what is kind of a $5 modification on stock hobby servos puts them in a league with the best robot motors you've ever seen. So give that a check if you haven't seen it. As an all-time favorite hack of mine. And if you added that to this robot design, it would just push it over the top.
Yeah, and if you're having trouble visualizing how this works, just think bimetallic strip, like the kind of thing that's in a thermostat or something like that, and it's got
exactly
iron on one side, brass on the other, and the differential expansion into heat bends it. This is the same thing, except the differential is from something that expands, the silicone, to something that doesn't, the fabric, and that causes it to curl around. I think it'd have potential for other applications, even moving the arms of a robot, all by itself. Forget about being a gripper or an actuator, just maybe even moving the arm of the robot, because you're curling 180 degrees, almost, actually even more than that, all the way back onto itself. So potentially has some use in other places. Up for me now is Remembering Heathkit. This one is ham radio gizmos going through all of the history, the corporate history, the memories of the Heathkit Corporation, which, if you're not familiar, was a major player in the hobby electronics space in probably from the 1940s to the 1980s or so, before they started kind of fading out a little bit. And Heathkit was where you went to buy kit versions of fill in the blank. It could have been any kind of electronic gear, stereos, color TVs, ham radio gear, especially ham radio gear. I remember the Heathkit catalog having, tons of test equipment, build your own oscilloscopes, your own signal generators. I remember the grid dip meter, of which Al is such a fan. Ton of different things you could buy and put them together yourself. The big attraction to Heathkit was not necessarily that you were saving money, although for things like color TVs, they were certainly advertising that, you would save money by assembling it yourself. But more, it was the experience of putting it together. And that was such a satisfying experience, right from getting your shipment from Benton Harbor, Michigan, where Heathkit was located, getting a box, taking all the pieces out, going through the instruction manual. And the instruction manual was really what you were paying for. The documentation on these projects was exquisite. We could all look at these manuals and learn something about technical documentation from them. They made sure you put the right pieces, the right parts in the right holes. and soldered them the right way. They even had soldering tutorial at the beginning of the manual in case you didn't know which end of the soldering iron was the friendly end and which one you didn't want to touch. All of this stuff was contained in this manual, plus the way they packaged the parts and made sure that nothing was left out. If anything was, you could call up the company and they would send it right to you. Their motto was, "We won't let you fail," or something like that, something along those lines. And it was a fantastic experience. I built one thing, a shortwave receiver, and it was one of the crowning achievements of my, my probably 12-year-old-ish time frame where I actually built this shortwave receiver and sat down and listened for DX signals all night long. Sometimes that's where my late night habits came from. It's just staying up all night and doing things like this and playing with my Commodore 64 later on. And all of this was very formative, and reading this article was kind of a cool review of everything that Heathkit used to stand for. Interestingly, and I didn't either knew this and forgot it or didn't know it at all, Heathkit started as an airplane kit company. So Edward Heath made airplane kits that you could buy for like $1,000 in the 1920s, which was a lot of money, but a lot less than it would have cost to buy a commercial airplane, if you could even do that at that point. Yeah, 1920s, you certainly would have been able to. Kit airplane business didn't work out, and the markets changed. World War II came along eventually and kind of reset everything. Commercial electronics took off as a field, and returning GIs looking for hobbies, they found Heathkit, and it took off as a big business. That unfortunately is nowhere to be found anymore. I understand the market forces that led to its demise, but that doesn't mean I don't miss it. It was nice to read about the early history of the company.
Well, my first quick hack this week comes from Toast, who has made himself a new and weird kind of typewriter. This is an entirely 3D printable typewriter where Toast kind of rotates the top of it and presses the keys down. They stamp down onto some carbon paper instead of an ink ribbon. And then it's got a neat ratchet mechanism that moves it on so that you can type in the next letter as you turn the wheel around. It's like kind of half Dymo machine. I'm not sure it's a typewriter, but it's a pretty cool 3D printed typewriter. Next up, tech. Terminal DAW does it in style. This is a kind of mashup between an Ableton-like interface and a tracker interface. And if you're a synthesizer nerd and have played around with a bunch of different sequencing options, you'll know what I'm talking about, and you should check this out. And if none of that made any sense to you, might not interest you. And last up, Liam, comparing AI for basic plant care with human brown thumbs is an absolutely hilarious read. He takes an ESP32 and instruments a temperature and light and soil moisture and water pump for plant care. And then he hands all of this off to Google's Gemma 3 AI and says, take care of my plant and make it live. He actually gives it fairly decent instructions, I thought, and it does fairly well in the beginning, but after a couple days switches in its mind the direction of wetter versus drier on the soil sensor, and it just starts overwatering the plant, and it just keeps watering and watering and watering the plant, because of course it gets wetter every time it waters it, and it interprets that as drier. The AI also knows that light makes plants grow, so it leaves the light on 24 hours a day, which, plants have circadian rhythms like we all do, and probably could use a little nighttime to respire. So, yeah, in long story short, the AI runs it out of water by completely soaking the plant, but it provides this fantastic commentary along the way. You should really go over to his website and read it. It's absolutely funny to hear the AI worrying about the plant drying out while completely soaking it.
Okay, first up for me with quick picks, quantum random number generators squirts out numbers via MQTT. This is a project from Sean Boyce. It does exactly what it says on the tin. This is just a true random number generator, but with a lot of interesting twists if you're into this sort of thing. It uses a pair of transistors to generate some avalanche noise. That's its source of entropy. Cleans things up with some comparators to make some square waves, and then runs a von Neumann extractor, whatever that is, to convert the waves into bits, and then makes it available on an MQTT stream. It's pretty cool. I kind of like the idea here. There's a lot of neat parts to it. And who doesn't love a random number generator? Next up for me, Onkyo receiver saved with an ESP32. This is one of those beautiful receivers that used to grace the shelves of the bachelor pads of the 70s and 80s that were fantastic receivers that had great amps in them. They sounded really good. This one was kind of on the cusp of the digital age and had some digital parts in it. The DSP inside of it failed. And in order to recover it, Bill Dudley went through the trouble of replacing the main microprocessor with an ESP32. It was basically running the same kind of code, but saved all that beautiful analog stuff, even though the digital end had shuffled off this mortal coil. And finally, quick and easy digital stethoscope keeps tabs on cats. This came from David Revoy, who had a cat that went to the vet, and the vet found a problem somewhere, said, why don't you keep track of the cat's pulse? All you need to do is get a stethoscope and take the cat's pulse. We'll be all good. Well, David tried that, but Jalouche the cat was not very cooperative, so he came up with this amalgamation of a simple, cheap lavalier mic and a cheap stethoscope. He lopped the head off the stethoscope, stuck the microphone in the remaining bit of tube, and then strategically positioned the stethoscope someplace where the cat would be sleeping on it. Between purrs and other noises, David was able to get a sound file that was easily analyzed on your favorite audio program, and he was able to see how many beats per second, beats per minute there were, and was able to help his cat out with this hack.
And I have to say, that's a marvelous pet hack. By the way, we're running a pet hacks contest. Go over to Hackaday and type in pet hacks. You'll find everything you need to know. This should be entered in there.
It should. I was surprised it wasn't. I thought for sure it was going to be one of those, but no, it was not. So David, if you're out there, get that on Hackaday.io and
take you 10 seconds to whip up an IO page, and then you're in.
That's right. Yep.
Damn Skippy. All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Tom Nardi's absolutely brand stinking new libOGC allegations rock Wii homebrew community. And this is a quite convoluted story, but at its base, it's a tale of open source libraries that may or may not have used other code inappropriately and then worked their way into other downstream code bases and what they should do about them. I think that's actually a neat question. But at the end of the day, it does look like libOGC probably copied some code from an open source library. You know, you're all saying, well, what's the big deal? The big deal is that this real-time executive for multiprocessor systems, RTEMS, is BSD licensed. And that means they have to acknowledge that they got it from RTEMS if they're going to use the code. In this case, it looks like they took a bunch of functions from it and kind of renamed the variables to fit in with their existing code base and just like cut pasted basically and then changed some of the names of the RTEMS code. Now, this was done about 20 years ago, maybe longer. Were standards for open source attribution different back then? I don't know. The BSD license was what it was back then and is what it is now. Viewed from a modern perspective, I think they should at least put in the README that they took some of these functions from RTEMS, and that would solve that problem. The other problem that may be more interesting is that libOGC is the Open GameCube library, and it is at the base of a whole bunch of Wii and other Nintendo emulation software. And emulation runs this kind of sketchy, thin line between legal, which is, you know, people just want to write software to use on these machines, or they want to, you know, use the emulations for writing their own software for it, and the illegal, which is that people who get root on these machines can then use them to run pirated copies of software and defeat the copy protection, right? And so these two are kind of, I think, inexorably linked. And that makes a lot of the people who write emulator software want to be extra squeaky clean so that Nintendo can't come at them. RIP Yuzu, for instance. And so when Hector Martin, who is lead at We Homebrew Channel, confronted the folks with DevKit Pro and libOGC about the cleanliness of their code, and they kind of said, well, it's really fine. He said, well, I can't do this anymore. I'm going to suspend We Homebrew Channel in protest. Now, viewed from today, of course, the BSD side of things could be cleared up by just simply adding a declaration to the code in libOGC that says a lot of this code was taken from RTEMs or inspired by routines in RTEMs, and that would suffice for the BSD. So they'd be out of the woods on that one. And the Nintendo code is a lot murkier anyway. The OGC team says that they reverse engineered this from Nintendo binaries, and then some people from the other side said, oh yeah, well, why do you have these variable names in there? And they said, well, we used the dev version of this that had the strings in there, and so we just reverse engineered it but used the string names that they left in the binaries. And things start to get a little murky at that point. And then it probably turns out that it was a dev kit, like a software development kit, and whether they should have had that or not is another question, because it should have been only licensed to people who had signed an NDA and stuff like that, right? Is this a copyright problem? I don't know. Is this a problem for downstream libraries? I don't know. Is Hector overreacting here? I don't know. Should he be shutting down his project instead of trying to help the libOGC people fix their problems? I don't know. Should the libOGC people be fixing their problems? I think so. Should everybody be helping each other instead of taking this headbutting adversarial attitude? I absolutely think so. I think there's a lot of room for improvement, and it's important because a lot of Nintendo console emulators rely on this code base. It's probably important to get this thing cleaned up. And this is kind of Tom's conclusion here, is that everybody agrees that some of this is dodgy. Hector's making allegations that it's illegal and fraudulent and, et cetera, et cetera. And I'm not sure that it is, but it's probably copyright infringing, which they could solve very quickly. And the other bits are, maybe a little dodgy, but reverse engineering is always a little dodgy. I don't know. I'm not a lawyer. All I know is that I wish all of these parties would get together, have a big love-in, fix each other's problems, and make things work again. Because, this does bring up the issue of if you can't trust the provenance of source code libraries that you then bring into your project, are you then liable for them? I see one possible way forward, that is fork OGC and make a clean version of it. Add the disclaimer that it uses this other code, and boom, that's done. Right? Like, some of these solutions are terribly, terribly, terribly simple and can be dealt with in the usual open source software means, which is fork it, fix it, and move on.
This one's by Al Williams, and it seems to have come about with some random browsing that brought about an archive of Radio Electronics magazine articles. This one's from August of 1982. The link in the article is the PDF of the entire magazine. Now, about the project itself, it's pretty cool. It's definitely not a beginner project. There's like 100 chips on multiple PCBs, one gigantic PCB. And what it's basically doing is taking a standard NTSC fast scan TV camera and converting that to slow scan format with a ripping frame rate of 1/8 of a hertz, sending the resulting image over the phone lines to be decoded by a similar box such as this to be displayed on a standard TV. All of the pieces, parts that make this work are extremely interesting, especially given that this is 1982 electronics, no microprocessors present in any way. It's all discrete logic chips, analog circuitry, and other wizardry that you'll really enjoy looking at. But that's not what I came here to talk about. What really got me about this article was the fact that up at the beginning of it, Al makes a really important point that I'd never really realized before. Hackaday is very much the descendant of the electronic magazines of the 60s, 70s, and 80s till they started fading out probably around the early 1990s or so, and just became PC magazines. But popular electronics, radio electronics, modern electronics, elementary electronics, all of these were magazines that I look forward to very much so every month with a trip to the grocery store or to the drugstore with my mom or my dad, convincing them to drop $1.25 or $1.50 on a magazine that would keep me occupied for days, months. I would read and reread these magazines over and over again. The really nice thing about this article is that it's got the full PDF of this issue of radio electronics, and going through all of the ads and all of the front matter and the back matter in these magazines, and seeing the way the articles were laid out is great. This is the stuff that got me into electronics. But the fact that Hackaday really is the successor to that scene, where we do exactly what those magazines did. We just do it faster. Send in a project, or you would possibly even work off of, not commission per se, but, assignment to build a project, and you'd send it in and write a description of what you did, bill of materials, PCB designs, or point-to-point wiring diagrams, or whatever to get your idea across. Take some pictures, and they would post this, and several months later probably the magazine article would appear, and you'd be the equivalent of internet famous at the time. And that's pretty much what we do. We take people's projects, we write them up, we celebrate them, and we show people where they can find the build files, if any exist, or we can just give them the idea that it's possible to build this, so maybe that inspires that in you. And I really appreciate the fact that my electronics quote unquote career, although I never really did electronics or electrical engineering or anything like that for a living, but still my life in electronics started with these magazines, and here I am 40, 50 years later, whatever it is, still doing it and doing the equivalent of what those magazines started in me. I'm doing that for somebody else now, for the community now. And that's also one of the things that looking at the back of this article, or the back of this magazine where this article appears, there was a community, because you could send in your problems. You're trying to fix a TV, and you were having a problem, so you write in and you say, oh, I replaced the yoke on an Admiral blah blah blah, and I'm still getting convergence problems. Anybody have an idea how to help? Send it to the editors. The editors would look it over, put it in their production schedule. A couple months later, that letter might appear in print, and then maybe a couple months later, someone else would write in and solve the problem. And so your bandwidth was really low. You didn't get instant feedback or anything even approaching it. But that was kind of beside the point. The real point to all of that was that there was a community, and even if you were physically disconnected from it, isolated it from it because you didn't live in an area where there was an engineering program or a lot of hobbyists or whatever, and you thought you were alone in your interest in electronics, you really weren't. You could look in the magazine and say, oh, look, there's, someone who's got the same kind of problems that I've got. It was a way to build a community, even if it was a very low bandwidth community compared to what we've got today. And we're doing basically the same thing. And I really appreciate that Al pointed that out over and above the interesting details of the project itself here.
I love that you bring up both those old magazines and Hackaday as this source for inspiration for hackery types, because it's true. That's exactly what it is. And I know I've been being inspired by Hackaday for 20 something years now, thinking of all of the projects that are on my to-do list. It's mind blowing. But what's funny is Al, even in this article, which is this kind of nostalgic look back at this incredible for the time technology, he managed to put another element on my to-do list. Thanks a lot, bud. So first off, I want you to consider for a moment how crazy this project was back then. You had to have a video camera, but then you had to have enough memory that you could store all the values from that image on the screen at that moment in time. And then you have to play it out over a slow scan TV, which uses audio modulation. So it's like, to play the picture back. And a slow scan TV picture is like 8 seconds or 20 seconds or 30 seconds. So this poor machine has to remember all of these bits for that long as it takes to play the sound back out, which back in the day was expensive. And then you look at the circuit board and it's all integrated circuits, and you had to stuff this thing in there, 100 of them. The author says, quote, "This project is not for beginners." And that's a friggin' understatement. And then Al's like, in comparison to all that, you could do this today with a PiCam. And I'm like, oh, you totally could do this with the PiCam for like $5 or something. And you just put a amplifier on there that plays on a speaker. You have it take a picture, convert it over, and go beep-loo-loo-loo-loo, and then you could play it anywhere. And then I'm like, and if you had a TFT screen and a microphone and another ESP, you could make a little player for it. And then I'm like, but wait, we have cell phones which have apps on them and screens already built in. And so you could just download a slow scan TV app and you could play it to that. This is why I read Hackaday, is because I need more projects on my to-do list. Like I need a hole in the head. But this one's fantastic because those little, whatever, Pi cam, those little ESP32 cams, I guess I'm thinking of, that cost like $5. It's got a cheap camera on it. It's got an ESP32. You just take a snapshot. It won't take you a weekend to program that up. 5 solder joints and you're done. Fantastic. This is like such a good project that I think I'm going to have to make myself audio slow scan TV broadcaster. Now all I need is everybody else in the world to listen for my pictures.
Like I say, that sounds like a perfect SuperCon project, a badge project, right?
Ooh, yeah.
Everybody warbling.
Everybody bring your slow scan decoders to SuperCon. We'll all be making slow scan TV pictures. I actually looked it up on Wikipedia. There's all sorts of different encoding formats. We might have to standardize on one. Decide whether we're going to do color, decide what resolution. Some of them take like 2 minutes to warble the picture out. I think that's a little bit of an ask. But I think like the quick black and white ones, 15 seconds, we can do that. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you want to follow the links, head on over to hackaday.com/podcast. And if you want to suggest something now that could be next week's links, send us a line, tips@hackaday.com. And until next week,
keep on hacking.
All right, all business. Are you about ready?
I'm done chewing, yes.
Oh my God, what a disaster-oo.
You sound weak.
I'm gonna die. Nah, we'll do this. We got this.
All right, here we go.
No t-shirt for you.
No t-shirt for me. I didn't press record.
I'm gonna cut that out.
Moving on.
What did I say? I said something super bright. And that is a wrap.